Okay, standard RP.2 is all about constant of proportionality. We're going to start with 2A. It's broke down into A, B, C, and D. Is it proportional? Looking at number 1, is there a proportional relationship here? Well, let's look at the fact that K is taking Y divided by X. So I can take any of these Y divided by X and see if they're the same. So 2 divided by 5 is 0.4, but then 4 divided by 8 is 0.5. So I'm already getting different ones. 6 divided by 11 is going to be a decimal that keeps on going. 0.54 repeating. So no. Explain. The values are different. Number 2, the table shows the number of red and blue flowers in several different bouquets. Are the quantities proportional? So let's find out. Let's take the first order pair and say, okay, 9 divided by 3 is 3. We'll take the second order pair. 15 divided by 5 is 3. We'll take the last order pair. 18 divided by 6 is 3. So they are all the same. So is this proportional? Yes. Y divided by X is equal each time. So they have the same constant proportionality. Number 3, select all the graphs that represent proportional relationships. These have two qualities. Number 1, they must be a straight line. And number 2, each must go through the origin, which is the point 0, 0. So this first one, it is proportional. The second one is not. It's a curve. This third one, it is proportional. This fourth one is not. It doesn't go through 0, 0. This last one is not because it does not go through 0, 0. Standard RP2B is about the constant of proportionality. It's this value K. And we know we can find K by taking Y and dividing X. So we're going to look at problem 2. The values in the table are in a proportional relationship. What is the constant of proportionality? Okay, well, we're going to find this by finding K, which is Y divided by X. We can test every ordered pair and say, okay, 24 divided by 6 is 4. 32 divided by 8 is 4. 40 divided by 10 is 4. At that point, you've done several, and that's enough, but we'll go ahead and say 48 divided by 12 is 4. So every time we get that K is 4. Answer choice C. Number 3, a graph has this equation y equal 2/3 x. What is the constant of proportionality? This fits y equal k times x, which is an equation for the constant of proportionality, and we find that that value is 2/3. Number 4, the graph shows a proportional relationship between the number of batteries and the number of packages sold. What is the constant of proportionality, and what does the constant of proportionality represent in this situation? Well, we can find it quickly by saying, okay, K is equal to Y divided by X, and I've got this ordered pair right here for 1. So I'm going to plug that in and say, well, Y is 1, X is 4, so the constant of proportionality is 1/4. What does it mean here? It means for, well, let me say that a different way. Each package, because it's saying one package has 4 batteries, so each package has 4 batteries. Standard RP2C is about writing proportional equations. These would fit y equal k times x. So looking at this first one, which one is a proportional relationship? Well, not the first one because it adds a number at the end. Not this one because x is in the denominator. Not this one because we have an exponent with x. So this equation, which could be rewritten as y equals 6/7 x. If you have the variable in the numerator, you can just pull it out from the fraction. Number 2, Robert makes $6.50 each hour cutting grass. Write an equation to represent his earnings E relative to the number of hours H that he works. Well, thinking about y equal k times x, this is like saying y equals $6.50 times x, but we know that it's per hour, so that means $6.50 times h hours, and that equals the total instead of y is his earnings. That's E, so we have our equation. Number 4, the values in the table are in a proportional relationship. Write an equation to represent this relation. Let's consider this like x and y. We're going to find k, and in this case, it's b divided by a. So let's take 4.5 divided by 1.5, and we get 3. Or if we were to take 9 divided by 3, we get 3. Or 12 divided by 4, we get 3. So the equation, if we were thinking about y equal k times x, is y equal 3x, but in this case, it's b equal 3a. Number 8, the graph shows the distance a car travels with respect to the number of minutes it has been moving. Write an equation to represent this relation using d for distance and t for time. What is the speed of the car in kilometers per hour? Well, let's figure this out. We're going to write an equation where d is distance and t is time. We know this. We know this ordered pair. And so we know y divided by x is 40 divided by 30, which is 1 1/3. So the distance d, that was here in place of y, is equal to 1 1/3 times x, which is the amount of time. Now, what's the speed of the car in kilometers per hour? Well, we have 1 1/3 kilometers per minute, so we've got to think of what that would be. One thing you could notice is that going back over here and saying, well, that's 40 kilometers in 30 minutes. Well, in 1 hour, that would be 80 kilometers in 60 minutes, which is the same as 1 hour. So 80 kilometers. Or you could say here, 60 minutes is 80 kilometers. Standard RP.2 unit rate on a graph. This would be such as saying y divided by x, where x is 1 because it's a unit rate. So we're going to look first at problem number 1. It says George has a graph of a proportional relationship. Which point should he look at in order to read the unit rate? Well, we just said it's where x is 1. And answer choice B, written as xy, is where x is 1. And we'll go ahead and note that, where x is 1. Number 3, the graph below shows the number of eggs relative to the number of cartons. Part A, how many eggs are in 1 carton? Well, we could figure this out by saying, okay, what is 1? We don't know exactly, but we can tell right here that the constant proportionality y divided by k is 30 divided by 5, or k is 6. So there are 6 eggs per carton. Part B, how many cartons are needed to hold 36 eggs? Well, we're thinking about where would 36 fall. It's going to be about here, something like, it looks like it's going to be 6 cartons. And we could check it another way. We could say, okay, 36 eggs divided by 6 eggs per carton is 6 cartons.